All right, guys, today we're talking about prime factorization. And prime factorization is where you take a number and you break it down to its prime factors. So let me give you a super simple example of this. So let's say we take the number 8 and we want to break it into its prime factors. So I'm going to just start with 2 factors. So I'm thinking, what 2 numbers can I multiply to get 8? And I'm thinking 2 and 4 because 2 times 4 is 8. Now, 2 is already a prime number, so I'm just going to leave that one alone, but 4 is not prime. So in prime factorization, I'm going to continue to break numbers down until I have all prime numbers. So I could bring my 2 on down because that's already prime, and I can split my 4 into 2 times 2. And I know it got kind of wonky there, so I'm going to rewrite it down here. So now I have 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. So the prime factorization of 8 is 2 times 2 times 2. Now, in prime factorizations, one quick note is we never include ones. And the reason is, what I could do if I added in ones is I could go on forever, because I could do something like this, times 1, and we could go on for infinity. So because I could add as many factors of 1 as I wanted, we just don't include any at all. So in prime factorizations, we never include the number 1. Another good thing to know about prime factorization is there is only one unique prime factorization for every number. So the only way to make 8 using prime factorization is 2 times 2 times 2. That's the only way to do it. So let's try another one. Let's try a little bit harder one. Let's go ahead and try the number 32. So we're going to start by writing my number up top, 32. Now, I always tell kids one of the easiest things that you can do with prime factorization is see if it's even. If it's an even number, you can always start by dividing it by 2, and that's a super easy way to start. Now with 32, some kids may not know what 32 divided by 2 is off the top of their head, so you also could choose to start with something else. So you also could instead maybe start with 8 times 4, if you knew that factor instead. Oh man, my pen got really thick there. Hold on, let me fix that. Okay, let's try this again. So I could also do 8 times 4. Now, neither of those numbers is prime, so in this case, I have to keep breaking down both of them. So let's start with the 4. I'm going to go ahead and break the 4 down into 2 times 2. And then I'm going to go ahead and just bring my 8 on down because I haven't touched that yet. Now I can break my 8 down, and I could do 4 times 2. And then I can also bring down my 2's. And the reason I'm doing this is because this should always equal 32. So that's 32. 8 times 2 times 2 is 32. 4 times 2 times 2 times 2 is 32. And these are all called factorizations. They're not the prime factorization, but they're a factorization. And then finally, the last one that I could break down is I could break down my 4 again into 2 times 2. And then I still have a 2 here to bring down, and a 2 here to bring down, and a 2 here to bring down. So the prime factorization of 32 is 2 times 2 times 2 times 2 times 2. And I could check that by doing a little bit of extra work here. So let's double check our work. And this is actually how you would do this problem backwards. So let's say you were given this and said, what is this the prime factorization for? So you could do it like this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So I've double checked my work. All right, let's try one more. Let's try a little bit of a harder one. Let's try, and I'm going to write it over here so that maybe I have a little bit more space this time. Let's try 120. That one's a little bit harder this time. So this time, there's lots of different ways you could start. You could start with 2 times 60, because 2 times 60 is 120. You could also start with 3 times 40. You could do 12 times 10. There's so many ways you could start here, and it really doesn't matter which one you start with. I'm going to go ahead and start with 2 times 60. Now my 2 is already prime. I'm going to go ahead and bring that over, and I think I'll break the 60 into 2 times 30, and that still equals 120. Now let's break the 30 down. I think I'll do 3 times 10, but you could also do 2 times 15. Lots of different options there. So 2 times 2 times 3 times 10 should equal up 120. Then my 10 is not prime, so I'm going to break my 10 down into 2 times 5. And I'm going to bring everything else on down here. All right, and it looks like all my numbers are prime because I have a 2, a 2, a 3, a 2, and a 5. Now, in prime factorization, we typically like to write this in numerical order. So I have a 2, and a 2. So I'm going to write this I'm going to write my factors from least to greatest. And then I have a 3, and then I have a 5. So let's double check my work here. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 5 times 24 is 120. Perfect. So that is prime factorization. We're just breaking down our numbers until we have a string of all prime numbers. There are never any ones, and each prime factorization is unique to one number only.